What's up, guys? Back with another educational video, and this week it's a study review. Well, not a study review because it's not actually a study. Breathe deep, big sigh. We're talking about, do carbs make you fat? Specifically, the most hardcore interpretation of the anti-carb literature out there. So there was a paper published in American Journal of Clinical Nutrition this past week, authored by David Ludwig as the lead author, also including people like Jeff Volek, Gary Taubes, Kara Ebeling, who are all well-known low-carb proponents. Now, I've actually met Jeff Volek when I was a graduate student. He was very nice. And I liked most of his work, but some of the things that were proposed in here, well, let's just say we're going to do a thorough analysis of this paper. So basically, the title is The Carbohydrate Insulin Model, a Physiological Perspective on the Obesity Pandemic. I'm going to do my best to summarize the carbohydrate insulin model of obesity, and you guys will provide the link to the paper. It's free, so you can read it yourself if you want. And if I misrepresent it, you're welcome to call me out, but I don't think I'm going to misrepresent it. Basically, in their introduction, they say that the most commonly held hypothesis of the cause of obesity is energy imbalance. That is, you eat more calories than you expend. And they don't believe that explains how people get fat. They believe in something called the carbohydrate insulin model of obesity. Now, there's a lot of different carbohydrate insulin models of obesity depending on what studies have debunked that particular model. The model then gets changed so that it hasn't actually been debunked by anything, but I digress. The current model that they're proposing goes something like this. Too many calories don't make us fat. What happens is we eat processed carbohydrates that raise our insulin levels. Insulin traps fat in fat cells, and since that fat is trapped in fat cells, we can't access it for energy, and this means that we overeat in response because our body is sensing essentially low fuel availability. So they're kind of saying that you don't get fat from overeating, you overeat because you get fat, or because fat is trapped, for lack of a better term. Now, I'm going to go into a lot of reasons why that has already been disproven, including a few nutritional studies as well as pharmacological studies. But I just want to take a few sections from this paper and talk about what they say, because quite honestly, this mechanism that they propose here is hacked together based on straw man representations of epidemiological data as well as rodent data. As if we don't have hundreds of human randomized control trials. So we'll get into all this. To sum up, again, it's not that eating too much makes you fat, it's that eating too many carbs or processed carbs increase insulin, trapping fat in fat cells. That causes you to overeat in response. And oh, by the way, it also decreases your energy expenditure, which Ludwig has published a few different papers suggesting that low-carb diets increase energy expenditure, and I'm going to specifically talk about why his results do not appear to be replicated and why I think that they are wrong. In kind of the introduction, they actually say in the second to last paragraph, and I quote, "Rapidly digestible carbohydrates acting through insulin and other hormones that they don't list cause increased fat deposition and thereby drive a positive energy balance." I thought you just said energy balance doesn't matter. Does it? Doesn't it? It seems to matter when it's convenient for this model, and then it seems to not matter when it disproves the model. So thereby, if you convolute the model enough, it becomes impossible to disprove, but I digress. Next, 2 paragraphs down, under the headline of Obesity Conceptualized as an Energy Balance Disorder, it says, and I quote, "Importantly, the energy balance model considers all calories metabolically alike for practical purposes." That's not true. That's not true. So first off, all calories are equal because calorie is just a unit of measurement. However, the energy balance model does not consider all sources of calories equal because protein has a much higher TEF than carbohydrate or fat. Your TEF is the amount of energy that's required for you to assimilate the nutrients out of the food you eat. So with something like protein, it's like 20 to 30% TEF, whereas carbohydrate is about 5 to 10%, fat is about 0 to 3%. Oh, look at that. Carbohydrate's actually higher than fat. Oh, how's that fit into your model? This is a straw man they're constructing here because they're trying to set up the argument that energy balance model says, see, they have to be wrong because they're saying all sources of calories are the same. No, different sources of calories have differential effects on not only energy output, but also energy input, because more fibrous sources of carbohydrate are also going to be much more satiating, and protein tends to be more satiating. Now, satiation also depends on the specific source of protein, carbohydrate, or fat. But if we look at unprocessed sources of carbohydrates and fats, guess what like the most satiating food is? Plain white potato. Oh, but the insulin! In the next paragraph down, it's energy balance and body weight. It's kind of a subheading. And it asks the question, does increased consumption drive growth, or does growth drive increased consumption? Neither possibility violates the laws of physics, but the two perspectives have fundamentally different physiological bases and implications. They're proposing the question. By the way, this is also a fallacy, the I'm just asking questions fallacy. This is actually, I'm quite sure that this is Gary Taubes writing this part because he's written this part in his books before. They kind of hang this all on, well, when you're growing up, you're growing and you're increasing your calories. Did the increased calories cause growth? Or were you increasing your calories because you were growing and that's more demand? So there's a few different really dumb fallacies with this example. The first being the growth in adolescence is mostly from lean tissue, which is quite energetically demanding. Secondly, the growth during adulthood after you've achieved most of your lean body mass, unless you're lifting, that's fat tissue. That's not energetically demanding. Again, a completely inappropriate comparison. But let's just run with that for a second. Guess what happens if children are frank deficient in calories or are on low-calorie diets? You see impaired growth. Now, how could that be possible under their model? Oh, wait, it can't. Then they kind of go into palatability and food intake, and I thought this claim was funny. No interventional studies in humans have demonstrated a causal relationship between palatability and obesity, controlling for confounding factors such as macronutrient composition. Basically what they're saying is hyperpalatability of processed foods doesn't explain obesity because they're not controlling for macronutrient composition. Well, no duh. Because guess what hyperpalatable foods are high in? Carbohydrates and fats. You're shocked that there's not high protein, hyperpalatable foods out there? Yeah, if you want to set this up with the constraints of, oh, you have to match macronutrients, once again, sufficiently convoluting the model to where you cannot possibly disprove it. Next thing I want to point out, at the end of the second page, they make a claim. The basic formulation of the energy balance model essentially disregards knowledge about the biological influences on fat storage. No, it does not. That's just an outright false claim. Of the things that make up your total daily energy expenditure and your total daily intake, that encompasses everything. If you are doing something that's causing fat storage and also trapping fat, you're going to see that reflected in total daily energy expenditure because fat is used as fuel accessed by the body when there's an energy deficit. Now here's one of my favorite parts. They start getting into the government regulations and they really try to construct this argument in a way to convince you of one thing when in reality the opposite is true. So they say, governments and professional health organizations heavily promote energy restriction and exercise. Nutrition labels on packaged foods prominently display calorie intake, and personal responsibility to avoid excess weight gain is emphasized in patient care. Nevertheless, obesity prevalence continues to increase worldwide, prompting spectacularly complex formulations of the energy balance model addressing myriad biological, behavioral, environmental, and societal factors converging on energy balance. with questionable practical translation. The government made you fat, bruh! This is down to the crux of the argument. Personal responsibility. They're saying it's not your fault that you're obese. The Carb-Insulin Model of obesity says it's not your fault. Energy Balance says it's your fault. So your model says overeating processed carbs makes you fat. So you're fat because you ate too many processed carbs. How is that also not your responsibility? If true, 6 of one, half dozen of the other. Regardless, let's examine these government recommendations for restricting calories, because that sounds very powerful. Well, the government has been saying this, and yet people are getting fatter. Guess what people have been continuing to do in spite of government guidelines? Eat more calories. They eat more calories. I'll find a chart from Stefan Guillenet where he used the US agriculture data, almost like a linear increase in calories. By the way, mostly from added fats. People make a big deal about sugar going up in the diet, but the sugar intake has been declining the last 20 years, while obesity has continued to climb. How does this fit with your model? So they go on to talk about how they really feel that a high glycemic load diet is what's causing people to become fat. Carbohydrates that have a high glycemic load, which basically means it causes more insulin release compared to low glycemic carbohydrates, and that's what's making people fat. If only we had randomized controlled trials where feeding was controlled and they varied the glycemic load of carbohydrates. Oh wait, they've done that and they've shown no differences in fat loss. When you vary the glycemic load, but you keep calories consistent, people lose the same amount of fat. In fact, there was one study where they had people either consume over 100 grams of sucrose per day versus around 10. They kept calories and macros the same, and guess what? They lost the exact same amount of weight. You can hack together epidemiology and rodent studies, but somehow human data didn't make it in. Looking at the thing that you actually care about, rather than doing all this like fancy nuanced stuff. One of my personal favorites is where they talk about processed carbs making you more hungry. And to support that, one of the references is a study in rats where they gave them brain lesions. Or you could just look at the human randomized control trials. But I don't know, that's just me and I digress. That's their model, by the way. Pretty convoluted. So I'm just going through a few more points that they bring up in terms of the mechanisms of this stuff. Under the section talking about insulin, they say in rodents, chronic insulin treatment increases food intake and adiposity, and these effects are dissociable. If you give exogenous insulin, you must increase carbohydrate intake and therefore calorie intake, because if you don't, the subjects become hypoglycemic and die, possibly. Consistent with this finding, mice with genetically reduced insulin secretion have higher energy expenditure and are protected from diet-induced obesity. So mutant mice are what we're down to here. We're using mutant mice rather than dozens or hundreds of human randomized control trials. My research was in rodents. Big fan of rodent research for a lot of different reasons. However, when all things are equal and you actually have human data that directly examines the thing you want to examine and you choose to cite the mouse data, it's because you don't want to talk about the human data. Here's one of my favorites. In humans, insulin and drugs that increase insulin secretion or adipose insulin sensitivity cause weight gain, whereas those that decrease insulin secretion, including alpha-glucosidase inhibitors, which functionally lower the GI of starch, cause weight loss. There was recently a drug approved for the treatment of obesity called semaglutide. And guess what it does? Well, one of the things it does is it's an appetite suppressant. So people eat less calories. There's that energy balance model again. It also increases insulin secretion. Hold up. Your model is saying all things equal, insulin makes you fat. There's a drug that increases insulin secretion and people drop on average like 10 kilos. It doesn't fit with your model. Furthermore, as far as alpha-glucosidase inhibitors, yeah, they lower the GI of foods because they inhibit carbohydrate breakdown. So you can't digest starch. It reaches the lower GI, your bacteria ferment it and create short-chain fatty acids, so you get some of the calories from it, but guess what? You're just getting less calories. Again, an example of them cherry picking to show you what they want to show you without talking about the energy component of things. Another thing they say, genetic variants associated with increased insulin secretion predict weight gain, including a bidirectional Mendelian randomization study. So I've read this Mendelian randomization study. Yes, they did find that people who secrete more insulin did tend to gain a little bit more weight. Guess what the insulin secretion explained? Anywhere from 1 to 10%. 1 to 10%, which means that it doesn't explain 90 to 99% of weight gain. Gee, I wonder what else would explain the weight gain. Oh, calories, that's right. Okay, here's one of my personal favorites. I feel like I've been saying that a lot, but this really is one of my personal favorites. High-fat diets result in more weight loss than high-carbohydrate diets. And they cite several different studies. As I like to do, when people make claims, I actually go and, read the studies. They cite a few different meta-analyses, so props for citing meta-analyses. However, the first one was from 2013 and included 13 studies. And guess what the difference in body weight was based on the summation of these studies? Less than a kilogram. Low carb versus low fat produced less than a kilogram difference of weight loss in favor of low carb. Guess what happens when you're on a low carb diet? You lose body water. In fact, it's usually more than a kilogram of body water if you're talking about low enough carb. So you're basically talking about a difference of body water. And even if you weren't, we're going to hang our hat on a kilogram difference of weight loss. That's the solution to the obesity crisis. If insulin is so powerful, as you've been claiming in this model, how could it only produce a kilogram difference of weight loss? And even in the meta-analysis showing the biggest difference, it was 2 kilos, one of which was probably water. Oh, by the way, they didn't control calories in any of these. There is one meta-analysis that controls calories, and guess what they found? No difference in weight loss between low carb and low fat diets. Funny how that works, isn't it? The other interesting thing is one of these studies they cite, reference number 103 for them, a meta-analysis by Mansour et al. At 6 months, they show a small difference in weight loss. They also looked at insulin. Guess what they found between the two diets? No difference in insulin. Huh, wait, but I don't understand. How could they produce differences in weight loss if there weren't differences in insulin? Could it be because one group ate less calories? I wonder why they didn't talk about Brian, did I miss that in the study? Where was that? Huh, weird. Also, I want to read you something from that study. So I'm going to read you from that meta-analysis a direct quote. Several studies showed that macronutrient composition did not seem to be the determining factor in effectiveness of losing weight when energy intake was also decreased. Low-carb dieters reduced the energy intake up to 30%, which was a significant reduction compared with baseline intake and comparable to subjects on the low-fat diet. These findings support the assumption that the weight loss observed amongst low-carb dieters is mainly due to reduction in energy intake rather than the macronutrient composition. Huh, funny how they just threw that reference in there and didn't talk about what the authors actually said. So they also did a subgroup analysis in this meta-analysis. And here's what they said about the subgroup analysis. In the subgroup analysis, we excluded studies with a duration of less than 12 months, so actually long-term, with high or unclear risk of bias, so they excluded those studies, and studies with 100% women or presenting intention to treat analysis. I don't want to get too far into it, but intention to treat analysis is essentially if somebody drops out of a study early before it's done, you can still keep their data and you call it intention to treat. So amongst those studies, the weight loss was virtually identical. Wonder how that could be. Oh, that's right, calories. Oh man. They also say the chronic effect of glycemic load on body composition in humans with control for energy intake has not been determined. False. As we talked about, there have been several studies that have varied glycemic load and shown no difference in fat loss or fat gain when calories are equated. So this is kind of funny. And part of it, because their model is so convoluted, they then bring in out of nowhere myriad factors of dubious relation to chronic energy balance, such as utensil size or plate color, influence acute consumption. What? That's like having a discussion about the weather and somebody's like, yeah, but have you noticed that the sky isn't red? How do you think that affects things? One of the last things I want to talk about is their claim that low-carb diets increase energy expenditure. Now, I've already done a video on this, but when we look at low-carb diets versus low-fat diets and their effects on energy expenditure, there have been 2 meta-analyses done. One was done by Kevin Hall, who's a researcher with the NIH, and that study showed basically that there was a small but not really practical difference in favor of low-fat diets on energy expenditure. But basically, there was no difference. David Ludwig reran that same meta-analysis, but this time he separated them into short-term and longer-term studies. Now, the long-term studies were cut off at 17 days. Now, this is very important. There's a couple ways to measure total daily energy expenditure. One of them is with what's called a metabolic chamber, and that is the gold standard method. It is a much more direct measurement. The other way in free-living people is with doubly labeled water. That is an indirect measurement, and that was validated against a metabolic chamber. In this study, when they had both metabolic chamber data and doubly labeled water data available, Ludwig chose to use the doubly labeled water data. That's because doubly labeled water has been demonstrated to overestimate energy expenditure on low-carb diets, because low-carb diets cause an increased production of CO2 above what would be predicted by the equations, and CO2 production is a big part of how that equation estimates total daily energy expenditure. So them choosing to just use the doubly labeled water data and show that there's this increase in energy expenditure with low-carb diets, that would be like me doing a study on body composition and having access to data where they took both calipers and DEXA and saying, you know what, I'm going to use the caliper data. Even though DEXA is the gold standard, it makes no sense whatsoever. But doubly labeled water, again, has been shown to overestimate energy expenditure amongst low-carb diets. And here's the rub. Let's say it was true. Let's say it's not just a data artifact. I went through the studies in the meta-analysis. Some of those studies actually measured body composition. So we're going to see increased fat loss, right? Nope. Not one single study where they control for total calories and protein and vary carbohydrate and fat in that meta-analysis done by Ludwig himself showed a difference in body fat levels. How is that possible? It's not unless your model's wrong. So here's something funny about talking about the Asian population, how they consume more carbohydrates, but tend to not be as obese as Western populations. So the quote is, however, such ecological observations are subject to multiple interpretations, among them that people in these rural societies had high levels of occupational physical activity and restricted food availability, both of which might offset dietary influences on weight gain. Hold up a second. Wait, hold up. What did he just say? They're increasing their calories out and they have restricted food availability. They're still eating the same foods. He just said, they just said, literally right here, well, these people probably didn't get fat because they weren't eating as much food and they were doing more activity. How can you, with a straight face, write that and then put all that stuff about the carbohydrate insulin model? Because exercise shouldn't even be a part of it, because calories out don't matter. Based on what you have said in this, that is the glycemic load, that insulin is what causes people to become obese. Exercise should not matter, and Gary Taubes has said as much in some of his writings. So another quote that I love, the average increase in body weight throughout the last half century is attributable to the storage of less than 1 gram extra fat per day, illustrating the difficulty in exploring causal mechanisms with short-term studies. So basically he's trying to use this to say, well, you know, there's so much nuance to this. It can't possibly be explained by energy balance. Yes, if you plot how much fat you've gained during adulthood over that entire time, it comes out to like 1 to 10 grams per day. They'll use this to say, well, see, if you cut, you know, a few calories out, nothing happens. Here's what they don't tell you. People don't gain weight linearly. They don't gain it linearly. In fact, in America, people put virtually all their weight on during about a 6-week period, starting during mid-November and going to the New Year. I wonder what happens during that time. Oh, they eat more because it's the holidays. In fact, the average American gains about 1/2 kilo to 2 kilos during the holidays every year, and they typically don't take it off during the rest of the year based on the data. Now, if you spread that out evenly across the year, guess what it looks like? Oh, it's just 1 to 10 grams a day. My recommendation to these folks is you should probably read more of the scientific literature. The next thing that was written has to be Taubes writing this. The failure of the low-fat diet for obesity, as advocated in the late 20th century, can be traced in part to reliance on weak evidence from short-term and confounded studies. No, it's based on the fact that people didn't actually do what the government asked them to do. Yes, they ate more grains. They also ate more fat and ate more total calories and did less activity. You left that part out, guys. All right, so let's do a real simple deconstruction of this, shall we? So first thing, the idea that insulin traps fat in fat cells, making it inaccessible and people overeat in response. Not true. So obese people actually have higher circulating levels of fuels than non-obese people. Furthermore, if you inhibit the release of fat out of fat cells with drugs, which you can do, they did this and they showed that a group getting that drug versus not getting that drug both lost the same amount of body fat. We've already talked about semaglutide, which increases insulin levels, but somehow people lose fat. Why? Because they eat less calories. Furthermore, if we go back to the actual human randomized control trials, of which we have many, but those trials that provided food to people, which means better adherence, and tracked body composition, we have over 20 of these, where they equated calories and protein. Guess what the difference in fat loss between low-carb diets and low-fat diets is? Nothing. Actually, it favored low-fat diets by about 16 grams more fat loss per day. Not really practical difference, but it certainly doesn't favor the low-carb diet. I am not saying a low-carb diet is not a useful tool for treating obesity. It absolutely can be. And many people have experienced drastic improvements in their body, their health, using a low-carb diet. It is absolutely a viable tool for treating obesity because many people find it satiating and it helps them reduce their calorie intake. Not because it's magic, not because the insulin fairy. I have no problem with people researching low-carb diets. In fact, the lab I came from at Illinois, I wouldn't say we were low-carb, but we certainly skewed towards the Mediterranean-style diet in terms of what we were testing on subjects. We definitely weren't high-carb. I'm not saying that these aren't reasonable treatments for people, but it's important to be honest about why they work so that people have options. Because if people believe that carbohydrates are what makes them fat, they're likely to make very poor choices in how they diet. And I will give you an example, and then I will let you go because this video is getting way too long. Ethan Suplee talked about how he lost over 300 pounds. He said part of that weight loss was using a low-carb diet, and he got to the point where he had trouble losing weight. And at the time, he believed it was because of the vegetables he was eating. He only later came to realize it was because of the enormous amounts of oil he was putting on his food. But because he believed it was carbohydrates that were making him fat, he felt like he could just put however much oil on something and he'd still be able to lose fat. Once he started controlling his calories, he was actually able to lose fat. Low-carb diets, completely viable for losing fat. Not magic, and do not appear to be physiologically superior for fat loss. But if you enjoy a low-carb diet and you're able to adhere to it, it may be the right diet for you, but not because of this paper. And one final thing I will leave you with. I feel like I've left you with about 5 final things. But one final thing, Occam's razor, which states that when all things are equal, the hypothesis which requires the least amount of assumptions is typically true. Energy balance is relatively simple with quite a bit of nuance mixed in. The carbohydrate insulin model of obesity is about as convoluted as the tax code. I'll let you decide. All right, catch you guys next week. I'm gonna go take a nap.